In this video, I'm going to introduce marginal analysis. We use marginal analysis as a way to decide what is the optimal quantity. We do this when we are faced with questions of how much or how many. How many hours should I study for my exam? How many milkshakes should I buy? These kinds of questions are best answered with marginal analysis. So after introducing this, I'm also going to show our graph, and at the end you should be able to sketch and interpret graphs for marginal analysis and also identify and apply the golden rule. So here is a example I'm using for Canon, and we're trying to decide how many Canon we should have. On our vertical or y-axis, we have the price measured in dollars for our marginal benefit or marginal cost. Remember, the word marginal just means additional, so this is what is the benefit and cost of one more unit. An additional unit gives us how much benefit, how much cost. And then quantity is on our horizontal or x-axis. Now, as you can see, what we find is that marginal cost increases. The sacrifice that we make for one more unit as we consume more units is going to increase. So marginal cost slopes up towards the sky, and you see the letter C there. It always reminds me of a cloud. So if you picture a cloud, always draw your marginal cost curve sloping up towards that cloud. Later on, we'll see that these marginal costs are what are behind our supply curve. And then marginal benefit slopes down. Later we see that it's the marginal benefit that is behind our demand curve. The B in marginal benefit reminds me of the basement, so the demand or marginal benefit here slopes down as if you were walking into the basement. So now I've added the golden rule here. Our golden rule is that in order to find that optimal quantity when deciding how much or how many, we always look for that point or that quantity where marginal benefit and marginal cost are equal to each other. So we've got our golden rule fulfilled here. We have MB equal to MC, and I've labeled that quantity, our optimal quantity, as QO here on our graph. Now, why is that the optimal quantity? If we go to quantities that are smaller than QO, why is that not better? Or if we go to quantities larger than QO, why is that not better? That's what we're going to look at next. So now I've added two different quantities, QS and QL, in addition to our optimal quantity QO. At QS, what we find is if we go up to our marginal cost curve, it's going to be at a value which is smaller than the marginal benefit of that quantity, because the numbers get bigger as we go up or further away from the origin. Because I run into the marginal cost curve first, that means marginal cost is less than marginal benefit. In other words, so we think, hey, should I have another cannon? And the answer is, hey, the benefit of one more cannon is bigger than the cost of acquiring that cannon. So yeah, we should have that cannon. And at every quantity up to QO, this marginal benefit is greater than the marginal cost. So we're always going to keep adding one more cannon, one more cannon, one more cannon. On the other hand, if we go to a quantity greater than QO, like QL, what we find is now that the marginal benefit is going to have a smaller value for that quantity than the marginal cost. So what we have to give up for another cannon is bigger than the benefit that additional cannon provides. We won't do that, right? We're not going to give up more than what we get. We clearly know that we want other things, and this is telling us that, hey, we would be in a better position if we had less cannon. And so we're driven back again to where the marginal benefit and marginal cost are equal. Again, the golden rule is that the optimal quantity to answer a question of how much or how many is always going to be where marginal benefit and marginal cost are equal.